Okay, starting to learn about integration. So finding the area under a curve. This is using an estimation, not a non-integration technique. Okay, but this is kind of what the idea of integration is. So we use derivatives of a equation to help us understand the slope, and integration would be us trying to find the area under a curve. So let's think about, like, if you have the velocity, let's say in physics, if you have a velocity and you derive it, that will get you acceleration, right? But if you have the velocity and then you integrate it, that would get you the distance, right? So if this is in meters, this would be, let's say, meters per second, and now this is like meters per second squared, right? So deriving and integrating. That's kind of the idea. You derive one way, integration just gets you the backwards way. Okay, so integration is the opposite of deriving, and so integration is going to help us find the area under a curve. Okay, so this first lesson is we're not even going to learn about how to integrate, but we're going to use how to estimate, a good idea of how to estimate this. So I have 4 methods here. You're going to use rectangles from the left side. You could use rectangles from the right hand side. You could use rectangles from the midpoints, or you could use a trapezoid shape. Okay, so the first one is, if you have the curve y equals x squared, you're going to estimate the area from 1 to 9 using 4 subdivisions. Okay, so y equals x squared, I'm going to kind of, it's not exactly how it is, but I have to fit it all under here, so. Okay, so 1 to 9, and I have to divide it up into 4 chunks. Okay, so this would be 3, 5, and 7. Okay, so if I want to use rectangles from the left-hand side, then it would look like this. Okay, so that would be areas from the left side. You can see that that's a low estimation, right? Because there's lots, right? You can see empty gap. If I want to use rectangles from the right-hand side, how is that any different? So 1, 3, 5, 7, and 9. So now I'm actually going to start my drawing from the right-hand side. So at 9 and over, 7 and over, 5 and over, 3 and over. So now you can see that I've overestimated the area. So the area truly underneath would be somewhere between those. Okay, so let's get the height. So let's plug it into x squared. So the height here would be 1. The height here would be 9. Here would be 25 and 49. Okay, so what's the area of a rectangle? The area equals length times width of a rectangle. So this first rectangle is a length of 2 and a height of 1. Second rectangle is a length of 2, a height of 9. A length of 2, a height of 25. A length of 2 and a height of 49. Okay? That is what's technically going on, but if you want, you can just say 2 times and then have it factored out, and this would be a shortcut. and I'm okay with that, but I want you to understand that you're doing like these 4 rectangles, which is a length times a width or a base times height. Okay, so that comes out to 168. Okay, so now let's get the heights of these rectangles. So the height of this rectangle is 9, 25, 49, and now this one is 81. Okay, so I'm going to do the long way. So each rectangle, so this is a 2 by 9, this one's a 2 by 25, the third rectangle is a 2 by 49, and the last rectangle is a 2 by 81. So again, if you want to write it in a short cut, that's what you're doing. So 328. Okay, so again, you can see that our area is probably somewhere between there in the 200-ish range. 200 and something. Okay, so now we're going to do rectangles from the midpoints. Okay, so my rectangle in the midpoint would look like that. So the midpoint is right here. So I get 4 subdivisions. Okay, can you see that's the midpoints? This is a better estimation I can see. Okay, so the x value here is actually 2. So the height of this is 4. Here, my point is at an x value of 4, so 16. 6, so this height would be 36, and 64. Okay, so now you're just doing the same thing. I'm going to do each rectangle. So this rectangle is 2 wide by 4 high. This rectangle is 2 wide by 16 high, 2 wide by 36, and 2 wide by 64. Same shortcut as well if you want to factor out the 4. You'll get a little bit better at that as you go. So 240 is the area on that. So that seems realistic and compared to my other ones, kind of somewhere in the middle region of that. Okay, and our last one is trapezoids. Okay, so draw my 1 to 9 again. Okay, so do you understand the kind of the gist of the shape here? That's a trapezoid shape. Okay, so we have 4 trapezoids. Okay, so the trapezoid area of a trapezoid is having like a base 1 plus base 2 and average them, and then times by the height. So in our case, we would need to know the average of that and then times by the height of it. Okay, so number 1, the first one. So actually here, let's label the heights here. This is a 1, 9, 25, 49, and 81. Okay, so we would say 1 plus 9 averaged out times 2 wide. The second one, the average between 9 and 25, and then it's 2 wide again. And then the third one is the average of 25 and 49 times 2 wide. And the last is the average between 49 and 81. Okay, so that's a long way to do it. So if you want a shortcut, obviously these 2's would all cancel. And you can see that I add 1 plus 2 9's plus 2 25's plus 2 49's plus an 81. So you can see that on each trapezoid you count this 9 because you count it twice. All these middle ones you count twice, and then the end ones you only get to count once. Okay, so that comes out to 248, which makes sense in that it's pretty close to also my estimation of the midpoints. Okay, and kind of right in the middle of the one that was underestimated and the one that was overestimated. Okay, I'll do one more of those. Area under 4x squared from 0 to 8. So this is a parabola right here. Okay, so 2, 4, 6, 8. Okay, so from the left-hand side, that's our underestimation. Okay, so this first rectangle is just no height. Okay, 2 squared is 4 times 4, so that's 16. 4 squared is 16 times 4, which is 64. 6 squared is 36. Times 4 is 144. Okay, so my area, so each rectangle happens to again be 2 wide. Okay, it's not always going to be that case, but this is 2 wide, so I'm going to say they're all 2 wide. So the first one is 0, 16, 64, and then the last one is 144. So 480 and 448. So that's an underestimation. Rectangles from the right. So here I'm going to start from the right hand side. So at 8, at 6, at 4, and at 2. Okay, so we know this was, oops, I don't want to put that there, I want to put this maybe there so it doesn't mix you up. That's 16 at 4, that rectangle is going to be 64, 144. And then this one is 8 squared times 4, so that's 256. So the area is, each one's 2 wide. So again, I am technically doing a 2 wide by 16 high, a 2 wide by 64 high. Right, that's what's actually going on, but we've just learned how to shortcut it. Okay, so that's 960. Okay, so that's a way overestimation. This is an under. Okay, let's do midpoints. So from 0 to 8. So the midpoint rectangles would be like that. Okay, so now don't forget that this is really at an x value of 1. So 1 squared times 4 is 4. 3 squared is 9 times 4. 5 squared is 25 times 4. 7 squared is 49 times 4, so that's 196. So the area equals that each one is 2 wide. Okay, so this is 672. Much better approximation. Okay, let's do trapezoids. So 0 to 2. 2 to 4, 4 to 6, and 6 to 8. We have all our heights from up here. So 0, 16, 64. One's 44, and at 8 it's 256. Okay, so I'm going to, I'll do the long way with you here. So the average of 0 and 16 over 2, and then 2 wide. The average of 16 and 64 by 2 wide. The average of 64 and 144 by 2 wide. And the average of 144 and 256 by 2 wide. The shortcut tells me to go 0 plus 2 times 16s, 2 64s, 2 144s, and 1 of the 256s. Alright. So this is 32, 128, 288, so 704 is the area. Okay, so you can see 704 pretty close to the midpoint, kind of in between of those.